so this lesson, we're going to call this 3.5b. So yesterday we did piecewise functions, and that was 3.5. So we're going to call this 3.5b because we're still graphing. So 3.5b, graphing absolute values. Absolute value equations. All right, does anybody remember what absolute value graphs look, or the absolute value is? It's what? Okay, absolute value always makes things positive, right? It's those bars. So when we have an absolute value graph, it's going to look like this. So the absolute value function is written like this. F of x equals a times the absolute value of x minus h plus k. F of x equals a times the absolute value of x minus h plus k. Does this look familiar to you at all?
No.
Okay.
Isn't this like a parabola?
Haven't we seen h and k before? We have, right? That was the what of the graph?
X and Y.
Nope.
The height.
Nope.
Time.
What? What'd you say? Say that louder, Samantha.
The vertex.
The vertex. H and K represented the vertex. This is going to be the exact same thing here. So our H value, whatever's inside the bracket, is going to be our X value. And the K value is going to be our Y value of the vertex. So another way to think about this, the H value is going to be the horizontal shift. You need to write that down. The horizontal shift. What do we have to be careful about the H value? We change the sign, right? So we're going to use the opposite sign for the horizontal shift. What about if the K value is our Y value? That means it's going to be a vertical shift. And we're going to use the same sign. There are a lot of tables. If you look over there, it says complete the table below. So we're going to do the first one by showing you what the table looks like. But after that, we're not going to use a table. Okay, we're just going to use the vertex. So it says, if this was the function, okay, if it looked like this, just f of x equals the absolute value of x.
You want us to write that down?
Sure. So this is just the plain Jane absolute value of x. If there was nothing else inside it, no other fluff. If I plugged a negative 3 in, see how they give you a negative 3 here? If I plugged a negative 3 in for x, what would that give me?
Positive 3.
Positive 3. So that means the absolute value of x is positive 3. What if I plugged a negative 2 in for my x value?
Positive 2.
I'd get a positive 2. What about a negative 1? Positive 1. What about a 0? 0. What if I plugged in a positive 1? What's the absolute value of positive 1? Absolutely not. Absolute value always makes things positive. It's always distance. Absolute value represents distance, and distance can never be negative. If you guys have seen Ferris Bueller's Day Off, when he tries to run the convertible backwards, right, to run the miles off, you can't go backwards in distance, right? So absolute value is always positive. So when I put a positive 1 in there, the absolute value is still just positive 1. Same thing when I put a positive 2 in there, the absolute value is still positive 2. And then the 3, positive 3. So what you have created in this table is x, y values. So the first one you've created, that was -3, 3. So those are the points that you created there. We don't need to write that out for each of them. But let's graph. Where is -3, 3? Go ahead and put that on your graph. The next point we have is -2, 2.
Didn't you go up and up?
I went -2, up 2. You do your x's first. And then back 1, up 1 gives you -1.
Oh, wow. It's
1.
just making a word.
It's not just going to be a line. 0, 0. What happens at +1?
Oh.
I go +1, +1, right? +2, +2.
It makes a V.
Ooh. So the absolute value of a graph, do you guys see that the y values, ooh, Leanna, you got to be careful on yours. You have things going down in that right quadrant. How did you get to that point?
You don't
It
go
said
over
-3.
one.
Oh,
You go to the right,
Yeah.
-3, and then up -3.
That's why I had to ask you,
Mhm.
because you know you go over 3, up 3,
Yes.
and you know you can go over 1 or whatever.
That's if you're talking about slope. We're talking about points.
Yeah.
Do you guys notice that none of these values down here are part of the graph? That's because that's where y is what? What is y down there? Negative. And we know that this f of x thing is always representing y. But if you're taking the absolute value, that means the number's always going to come out to be positive, right? So you're never going to have y values that are negative in this type of a graph. Now, there might be a time where the graph flips over the x-axis, and we'll talk about what that looks like. But just from this graph, this is called the parent graph. The parent graph is like saying the original graph. Okay, so this graph that starts at 0, 0 and goes up 1, out 1 on both sides, this is called the parent graph.
Is it possible for an absolute value to become negative when using a type of equation?
Yeah, we're going to look at what that looks like. Yeah. So what is the domain value here? What is the value of the domain? Think about what are the x's that it's going to cover. John?
3, +3.
Okay, but did you draw arrows on the ends of yours?
No.
Okay, so arrows mean that it's going to keep going on the x-axis, right?
So, infinity.
So it's going to be negative infinity to positive infinity.
But it's not hitting a negative number yet.
We're on the x-axis. It's going to go x-axis, side to side, right? Left to right. All right, now you're right. On the range, we're not in the negative zone. What's the lowest y value that it hits? 0. And then I'm going off to where?
Infinity.
0 to positive infinity. Okay? So we can identify the domain and range from our graph. Questions on absolute value. This part up here is going to be uber important for you, especially as we go through the second lesson today, lesson 3.6, okay? All right, so the graph looks like a what shape? Like a V. Go ahead and put your V there. And then the turning point is called the what? That turning point or that point where it stops going down and it goes back up. What's that called? The vertex. Okay? So the graph looks like a V. Oops. The turning point is called the vertex. Okay? All right, then it's going to tell you how to use the table. You don't need to read the directions on how to use the table. We're going to do it together. Let's look at number 1. Okay? So it says graph each equation, use the domain and the range. Find the domain and the range. So our x values, it doesn't matter which x values you choose. A good range to start with, though, is -3, -2, -1, 0, 1, 2, 3. That's just a good range to start with because that means you're dealing with numbers right in here. Okay, so your graph should stay right around there. So go ahead and fill your x values in with -3. We just are choosing those randomly, but not really random because I'm telling you.
And that's the ones we're gonna use.
To plug in. Yep, we're creating points so that we know what this graph looks like. So when I take a -3 here and I plug that in for my x, right? So I get -3 minus 4. Actually, let's write it out here to the side. So if I have the absolute value of -3 minus 4, what is -3 minus 4? -7. So what's the absolute value of -7? +7. So that means that is the y value that goes here. Okay, what happens when you plug in a -2? Well, -2 minus 4, we're plugging it in for the x up there. What's -2 minus 4? -6, but the absolute value of -6 is +6. Okay, then what about -1 minus 4? -5, and the absolute value of -5 is +5. 0 minus 4, -4, right? But then the absolute value of that is +4. Now, what about +1 minus 4?
-1.
No, +1 minus 4 is -3, but the absolute value of -3 is +3. Okay? Then what about when it's a 2? Okay, +2. And then 3, -1 turns into a +1. So this is going to look just like a line, right? Okay. So let's go ahead and plot these points. So you have the point -3, 7, -2, 6. Go ahead and plot your points. Now your graph is creating a what? A line. But what shape did we say absolute value was supposed to be? A V. So that means we haven't found where it's going to start going back up. We haven't found the vertex yet, right? So if we are thinking about what we said at the top of finding the vertex, remember we said we had f of x equals the absolute value of x minus h plus k. Remember there was our vertex, h and k. Okay, so what's the h value in this equation? What is it? -4, right? But we said, what do we do with that h value?
Make it a positive.
We make it the opposite sign. So our vertex here is +4. What's the k value? Ooh. Notice the k value is out here, right? What number is out here? Nothing. Don't say 1. I don't see 1 anywhere. It's nothing, and nothing as a number is 0. You could, if you wanted to, write +0. So our vertex is at the point 4, 0. So have we even on our graph reached the vertex point yet? Okay, so let's put the vertex point on there. 4, 0, we are super close. At this vertex point, what's going to start happening on the right side of this point? It's going to start going up, right? And if we wanted to use a graph, we could, okay, I'm sorry, a table to continue going out. If you chose like, let's check this real quick. If I chose 6 on my x-axis, if I chose 6 and I plug that in, what is 6 minus 4? 2, and the absolute value is 2. So at 6, is it at 2? It is there, right? So if you wanted to choose these x values to keep your table going, you could. And you're going to see that it's catching right there, okay? So I'd like you to look at the domain and range, see what you can figure out with the domain and range. So for the range, we said negative infinity to positive infinity. Okay? How did we do that? So do you see how your graph is here? And eventually it's going to domain is all the values of x. So eventually this arrow is going to catch all the values on the x-axis, right? Because your graph is going to continue to go like this. So you're going to get all the way to negative infinity and all the way to positive infinity on your x-axis. Okay? Then what about our range? Someone raise your hand and tell me what you got for the range. Crystal.
0 and positive infinity.
0 to positive infinity because we're going up, right? So this is the lowest that it goes is 0, and then it continues to go up to positive infinity. So what's the lowest on the y-axis that it goes? 4 would be here. Did it stop at 4? Nope, it went all the way down to 0. Okay. We're going to do another one. Okay. So on number 2, I want you to do me a favor. Block this 2 out on number 2. Let's just do x plus 6. Okay. So the absolute value of x plus 6, and then let's put a plus 1 on the end. So that you can see what this looks like.
I thought it was 0.
It is, but I'm changing the problem so that we can have something else. Okay, that was a good question. We're not just adding it just for the sake of adding it. I'm changing the problem. So pretend like it already says plus 1 on it, okay? All right, so now, what is our h value here? 6, right? But when we pull it out, it's actually a negative 6. So our vertex is negative 6. What is our k value? 1. So my vertex is at the point negative 6, 1. All right, so let's find where negative 6, 1 is. And instead of making a table, the number that's out here in front of your absolute value, that number tells you at what rate you should be going with your points. So, for example, is there a number out there in front of the absolute value? There's a 1, right? I mean, we don't see it, but we could say there's a 1 right here. That's really saying that's your slope, 1 over 1. So that's what it means with your points. You're going to go up 1 and over 1, up 1 and over 1, both directions. Up 1 and out 1. So that slope there in front of your absolute value tells you at what rate your points are moving. Okay, so if that was a 1, it's up 1 over 1. So this is what my graph should look like.
So, would a general rule of thumb be for graphing these things? If we know what our vertex and
Slope.
are, can we just graph from that point?
Yes, you should not. You do not need to make a table. Okay. Anyone have questions as to how I got this graph on there?
You just put a 1
I
outside of the...
right, because I changed the problem. I'm pretending like the problem already said plus 1. Okay, so like we'll get into a couple where their problem is already written
But I'm
there.
talking about the blue in
Oh,
the front.
yes. This one out here was already there. It just doesn't show up, right? There's no number there. So just like in front of x, right? If you had x plus 5, in front of x is a 1, right? We just don't write it. So same kind of concept here. If there's no number in front of the absolute value, it's always just a 1. Yep. Taylor? Okay. Mitchell, what is going to be our domain here? The x values.
It's going to be your negative 6.
Okay, so think about, it does start on negative 6, right? But do you agree that this is eventually going to go off all the way to where? Negative infinity, right? It's going to stretch that x-axis and it's going to keep going that way. Same thing with the right side, right? It's going to continue going off that way to where? All right, so it should be negative infinity to positive infinity. Can I give you a hint? What have we noticed about the domain in all three problems that we've done so far? So your domain is always going to be negative infinity to positive infinity. Okay? Your range is what's going to change. Okay, Ashley? These are brackets, right? Up there, this one should have been a bracket here. I'm sorry. Because you can include 0. It touches 0, right? And number 2 or number 1, it touched 0, so I need to include 0. So what's the lowest y value this blue graph goes? 1, right? Is it touching 1? Is it at 1? So then I need a bracket, thank you, Ashley, around 1 to positive infinity. If you are getting confused on brackets and parentheses and all that kind of stuff, I'm not super concerned about that. Okay, I just want you to get the numbers right. Okay? Yeah.
Is it because, okay. How did you get the positive infinity?
The range? Okay, so I start the lowest y value. The lowest y value is 1, right? And then it's going up. The graph is opening up. So it's going to go all the way up to positive infinity. It'd go down to negative infinity. Yep, and we're going to do a couple where it goes upside down. Okay, number 3. We're going to find the vertex first. Find the vertex first. Remember, if you need to write your form up there at the top, the form is f of x equals a. That a tells us kind of the slope, remember? X minus h plus k. Is there anything inside there with that x?
Oh, no. There's a 1. There's a 1, yeah, there's a 1.
There's a 1 in front of the x, but is there anything in the h position?
No.
It's going to be 0. So when there is nothing in that h position, it is a 0, comma what?
5.
5. 0, comma 5. So we're starting this at 0, 5.
And wouldn't the 5 be negative because it's the opposite?
So we only do the opposite of which variable?
If it's negative.
Of which one, h or k?
H.
Only h. What is the slope that we're using here? 1, right? So our points are going to move up 1 over 1 over 1 over 1. Up 1 over 1. Both directions.
So if we were to throw a number in her, there's, let's say, 2.
We'll do that in just a minute. Good question, but hold that thought. Okay, one of the things that we haven't done yet is I want to draw the parent graph on here, and I want to talk about this. If this is my parent graph that starts at 0, this was the very first one that we did. If this is my parent graph, what has happened between the parent graph and the one we just graphed? What did it do? It's not. It shouldn't be closer together. Mirror means it reflects. Where did it move? Up. It just moved straight up, right? How many? 5, right? It was just a straight up move to 5. Because this out here we said was the vertical shift. Right? Remember we said that on the very first page? This is your vertical shift. So we just took your parent graph and shifted it up 5. Nothing else is changing. If there's something on the inside, like look back at your question number 1. Go back and look at number 1. If we were to draw the parent graph, I'm going to draw it on number 4 here so you guys can see it. It started here at 4, 0, right? It went like this. If this is the parent graph, what happened to it? It shifted which way? Horizontally. Because where is that negative 4? Where was that negative 4 on number 1? Look at number 1. Where's that negative 4? It's in the inside, right? So if it's in the inside, we said that H value is a horizontal shift. Remember that? So if it's in the H, it's a horizontal shift. If it's a K, it's a vertical shift. Okay. Let's do, you guys don't have any blank places. Go back to your first page. Go back to your page, and right here, underneath absolute value functions, you guys have some space here. Okay? We have drawn the parent graph over here. You guys all have the parent graph there, right? Starts at 0. Okay, so if I tell you this, f of x equals the absolute value of x plus 3. Write that down. We're going to put two graphs here, okay? So put that down, plus 3. Again, we're going to draw two graphs here. Okay, so you have your parent graph on this graph, right? Where is this vertex going to be?
It's going to shift over 3.
Okay, but what do we have to remember about the H value?
It's in the opposite direction.
It's in the opposite direction, right? So this is going to be -3, comma, what's the K value? 0. Is everyone okay with that so far? Finding your new vertex? Hang on. Okay. When it's the H value, we always do the opposite sign. That's what we've talked about for 20 minutes, back and forth, right? So when it's the H value, it's the opposite sign. So if this is a +3, when it comes out, I'm writing a -3 for the vertex. You are correct that the absolute value cannot be positive, but we're not figuring out what it is when we plug in for x. We're just looking at the H value, okay? All right, so this means I'm going to draw it on my parent graph. I'm starting at -3, 0. And I'm going to draw it. What does the shift look like on the parent graph here? Where did we go? Horizontal, right? I need you to tell me horizontal or vertical, okay? So it's a horizontal shift, which direction?
To the left.
To the left. So when it's inside the parentheses or inside the brackets, let's write this. Horizontal shift. And we're actually going to put -3 because it moved back 3. What if I did this? F of x equals the absolute value of x minus 2. Okay, so that's going to be our second graph. F of x equals the absolute value of x minus 2. Hang on. Write your vertex right underneath this, what you think the vertex is going to be. Someone who I haven't heard from yet today. What is this vertex? Brooklyn. +2, 0. So if I were to draw that on my graph, I'm here. +2, 0. What has happened between my original and this new one? Horizontal or vertical shift? Horizontal shift of +2.
So if the number's on the outside of the two little things, whatever is on the outside, that's going to be your vertical shift.
Exactly. And if it's inside, it's a horizontal shift. Okay? So we learned that by discovery. We said if it's inside my absolute value, it's going to be a horizontal shift. But we have to be careful that it's the opposite sign when it's inside. If I'm on the outside, that's a vertical shift. Okay? So let's now go and do example... example 5. Let's go do example 5. Okay, so what's different about example 5 that we haven't seen yet? Okay, it's got a negative, so we're going to hang on to the negative for just a second. What is the vertex here on number 5? Excuse me.
-1 and 0. I mean -1 and 0.
negative 1, 0, right? So, yep, on number 5. Negative 1, 0. So we know because the 1 is on the inside, what kind of shift is this? It's a horizontal, right? But it's which way? Are we going to move to the left or are we going to move to the right?
We're gonna go to the left.
We're moving to the left because it's the opposite sign. The horizontal shift is always the opposite sign. So let's make ourselves a note here. I think it's helpful to write this out. Horizontal shift, negative 1. So now I'm going to write my new vertex is at negative 1, 0. Now, what is the slope here? John? It's negative 1 over 1. You guys see that? The slope here is negative 1. Right? So that means I'm going down 1 and over 1, down 1 over 1, down 1 over 1. But we know it does this, it mirrors it on the other side, right? So I'm still going down 1 and out 1, down 1 and out 1.
But an absolute value can't be negative, I thought.
You're right. But do you see how this negative is on the outside? So if I had the negative absolute value of 5. Okay, so if I cover up this, what's the absolute value of 5? No,
5.
5. Then I apply the negative. Now it becomes negative 5. Because the negative is on the outside, it's like saying this is a negative 1 times the absolute value of 5. So what was the absolute value of 5? So if I cover this, what's the absolute value of 5? 5. But then when I apply the negative 1, 5 times negative 1 is negative 5.
So the absolute value brackets act as a multiplication.
Yeah,
from
kind
the
of.
outside?
Yep, kind of way to think of it, yeah. Okay, so this graph is actually going down because the negative applies after the absolute value is taken. Okay? So let's do the domain here. Domain is still stretching, right? You're still going to go all the way to the left and all the way to the right. Correct? On your domain is still going to be negative infinity to positive infinity. Now, what about the range? What is, this time, what's the highest range value that you have, Donald?
Negative 1. 0.
0, right? It goes on your y-axis, it goes all the way up to 0, okay? And that's the highest, right? So that's, I'm going to put this one over here because that's the highest. What's the lowest? Negative infinity. I used a bracket around 0 because it includes 0. Okay. All right, on number 4. This is what I want you to do on number 4. I want you to I'm going to change the problem on us, okay? Not because you're just allowed to, but because I want to show you a different kind of an example, okay? So we're going to take this 1/2 out, okay? And we're going to put it on the outside. So that's going to be your what there? Your slope. Okay. So the first thing to do is to find your vertex. So this one has 2 shifts, right? It has a horizontal shift and a vertical shift because you have a number in for your H and your K. Be careful about your
Negative 1 and negative 4.
Okay. Now I would like for you to do it quietly so that your classmates have a chance to answer it on their own, please. Find the vertex, put your vertex point. And then look at your slope. Okay, so our vertex is at -1, -4. But what's happening with our points? We're going up 1 and then what? Out 2. Right? So this graph is actually, whoops, wider than the parent graph. Would you guys agree with that? It's actually wider. So the number in front changes the width of the graph. Okay? What if it was like 5 over 1? So what if it was a positive 5 out there? 5 over 1, you don't need to draw it, but just look up here. If it was 5 over 1, I would go from here and 1, 2, 3, 4, 5, up 1 over 1, 1, 2. What kind of a graph would that look like? Really what? Really skinny, right? So if your slope value is a number that's greater than 1, it's going to be really skinny. If it's a number that's less than 1, it's going to be really fat or wide. Okay? That's called a dilation. So that was just an extra example.
Would this be considered an absolute value parabola?
No, because it's not x squared. Okay, so let's find the domain and range of this one. What's our... Oh, man. I need like a... This keeps happening. Okay, what's the domain value, Lexi? What's your domain? Negative infinity to positive infinity. Okay. Brooklyn, what is your range?
-4 to positive infinity.
Perfect. -4, and we included -4, right? It touched -4, so you need a bracket around -4 to positive infinity. Okay?
So, if it's a negative outside the,
Absolute value.
does that mean it's going to go down
Yep.
instead of that?
Yep, always. So if there's a negative on the outside of the absolute value sign, yes, it's always going to go down. Okay? You only have 4 of these to graph, so let's look at page 21. I want to change a couple things on page 21, though. Okay, so on page 21, you have homeworks 1 through 4. All you're doing is graphing. But what I want you to do is at the top of the page where it says give the domain and range, you don't need to fill the table part out, okay? But where it says give the domain and range, I want you also to tell me, write the shift. So you're going to write the shift. Write that down in your directions. Right there next to give the domain and range. Write the shift. So if there are 2 shifts, you're going to say horizontal shift of +3, vertical shift of -2, whatever it is. Okay? So not only are you going to graph it, finding the vertex, you're going to give me the domain and range, and then you're going to tell me what the shift is. That is part of your grade. So if you don't tell me that, you're going to miss points. Okay? On number 3. Okay, on number 3, instead of the 3 being inside the brackets, I want you to take the 3 and put it outside the absolute value, out in front. So on number 3, scribble that 3 out on the inside and put it on the outside, acting as the slope. Same thing with number 4. Take the 2 out, and that will be a -2 in front then. Okay? Any questions about that?